There are over 1 billion metres of rail track on our planet. Enough to carry a train round it 35 times. But which is the ultimate railway? We'll spotlight 5 awe-inspiring combinations of train and track to discover which moves people the fastest.
As a train driver, I'm so proud to be at the top.
Which goes furthest underground? Which system holds the most weight?
And just take off because then you might break the train.
In our search for the true giants of engineering genius, we've travelled the globe, testing, analysing, rating, to establish the best of the best, the world's most extreme railway. 40% of the world's freight cargo travels by train. Globally, passenger numbers now exceed 1 billion a year.
There's more stuff being moved around the world today by trains than at any time in history.
We've selected 5 extreme railways for scrutiny. In Brazil, combining a sawtooth track with the world's strongest train to carry huge amounts of iron ore, the MRS. In Italy, ultra-fast thanks to an F1-style pit operation, the Italo. From South Africa, another iron ore line snaking off to the horizon, it's the Transnet. And beneath ancient Istanbul, stretching between 2 continents, the Marmaray Metro project. Finally, 90 trains a day make their way through the rock of the Swiss Alps via the Lochberg Base Tunnel. So, 5 railways, 5 extraordinary feats of engineering. We're going to rank them according to 5 key criteria and discover which is the ultimate. Our first category, speed. Which railway is fastest? Our 5th place railway isn't fast, but it still demands the most powerful train in the world. It hauls hundreds of tons of Brazilian iron ore at a rate of 30 kilometres an hour. It's the MRS.
The surprising thing about Logistica is it goes slower downhill than it does back up. But the whole point is to keep this massive weight under control.
4th, the Marmaray project. When it's complete, its average speed is expected to be around 45 kilometres an hour.
It doesn't seem like an impressive speed until you look at the number of people who are travelling at that speed. This railway is shifting 75,000 people every hour in each direction.
In 3rd, the Transnet Rail. It travels at 60 kilometres an hour, but it is like moving an entire small town, buildings and all.
Just think about it, it's 4 kilometers long. It has 300 plus wagons and 8 locomotives to drive this massive, huge train. It's just incredible.
Our 2nd place is the Lochberg Base Tunnel, clocking up a maximum allowed speed of 200 kilometers an hour.
200 kilometers per hour is a very high speed for a train to run in a tunnel, and it's only possible because of the ultimate trust in the safety systems that the designers have.
But at number 1, turning rail into racetrack, the Rome-Naples line. Its high-speed Italo trains are permitted to travel at up to 300 kilometers an hour. But given the chance, they could go much faster.
The company that set up this railway was started by the chairman of Ferrari. I can certainly see similarities.
This railway pairs cutting-edge technology and raw power to deliver one thing: speed.
My name is Alessandro Salerno and I work as a high-speed train driver. It is amazing to drive the Italo high-speed train.
they could run this with passengers safely at over 360 kilometres an hour. But in a prototype test, they managed to clock up over 570 kilometres an hour.
They've slashed 40 minutes off the journey time between Rome and Naples. But none of this would be possible without a massive operation behind the scenes.
This is the main workshop where we carry out all maintenance on trains.
Today, Diego Cutolo is in the hot seat, heading a team of 180 mechanics racing against the clock to carry out repairs and maintenance. They know that if they stop, the railway will grind to a halt. Or worse.
Every second the train is not on the track is costing a mammoth amount of money. And building a high-speed railway is an incredibly expensive thing to do.
Every repair job Diego oversees is under massive time pressure. But the train that's just come in has what could have been a catastrophic fault. A damaged axle. If it had completely failed at 300 kilometers an hour, the results might have been disastrous. Now Diego's team have just 3 hours to get it replaced.
The mission is to recover the train, repair it, to avoid that the train will break outside.
The fact that the fault was identified in time is down to a revolutionary new system. Sensors on board each train constantly measure all aspects of performance. They relay data back to a central control room, where warning signs can be spotted early and the repair jobs scheduled. It means that Diego's team knows what's in store and can hit the ground running. Now they have a fighting chance of getting the axle replacement finished on time and getting the train back out. The Rome-Naples line took 15 years to build. It was astronomically costly. It now carries 23,000 people every day at previously unheard of speeds. Thanks not only to this slick operation, but to a revolutionary piece of train design.
The most difficult thing is to synchronize all workers' efforts to get the best in the less time possible. That's the real challenge each day we face.
The axle is part of a unit called a bogie, and it's key to what makes this system a world beater. It's radically different from a conventional train.
Typically, trains have got carriages with your passengers and locomotives to provide your power. The Ferrari train uses space efficiently. It's dropped its drive engines inside the bogies, sitting underneath the joins between the carriages, so that the whole thing operates as one unit.
Shrinking the motors to fit inside the bogies means they can be placed to distribute power evenly along the train.
You get a lot of advantages for the dynamic of the train, for the braking system, for the traction system.
2 hours gone, and the axle replacement is complete. Now the team is on a 60-minute countdown. Every train leaving the maintenance area must go through the same battery of checks.
We are carrying out 1 hour check on this train. This is our main challenge every day. We have to do it in 1 hour or less than 1 hour.
It covers everything, from big stuff like the brakes, to the door mechanism, the blinds, even the intercom.
Welcome on board, Italo.
And every system is computer monitored.
If the test is okay, then you will see on the other display all windows green.
And as soon as the hour is over, back up to speed. Some kids want to be racing drivers, some want to drive trains. But thanks to Diego's team, Alessandro can do both. And his 400 passengers can get where they need to go. Fast.
This is a train that thinks it's a racing car.
At the end of the first round, the Italo high-speed railway takes the checkered flag. But how will it compare when we look at our other categories? Weight, tunnelling, and next, hill climbing. We're testing, analysing and ranking 5 of the world's most extreme railways. Thanks to its speed, the Italo, the Ferrari-inspired monster that thinks its train's a racing car, has pulled away in front. But will it still be leading when we finish the next round? It's gradient. What's the steepest slope our trains and tracks can deal with?
Trains are really good at travelling long distances very efficiently. They've got a very low rolling resistance on the wheels. But having low resistance on the wheels makes them incredibly bad at going uphill. They've just got no grip. So great on the flat, but really bad going up hills.
In 5th, the Transnet. The worst its monster trains have to face is an incline of 0.4%. That's a 1 metre climb every 2.5 kilometres.
With a train as long and as heavy as this, it's no wonder the engineers put so much effort into keeping that railway as level as possible.
In 4th, the Lochberg Base Tunnel, 1.3%. That means it takes about the length of a football pitch to climb just 1 metre.
The one advantage of building a tunnel through all of that rock is that you can keep it horizontal.
3rd is the Marmaray, the subterranean rail complex taking shape beneath Istanbul.
The most impressive thing about this project is how deep it sits below the ground. The challenge isn't really how steep the track is, it's getting the train down there in the first place.
At number 2, we have the Italo train. As it carves its way from Rome to Naples, it rockets up slopes of just 2.1%.
This train isn't built to climb, it's built to race.
But at number 1, with an ability to shift huge loads up and down hills 4 times steeper than anything the others could handle, it's Brazil's new mountain-defying monster, the MRS. Sao Paulo, Brazil. On this 10-kilometre track, after 4 years of work, the world's strongest train is about to undergo its final test drive.
Aqui é o painel do maquinista, o painel central dele, né, onde tem acesso a todas as informações de condução do veículo.
The man at the controls is veteran driver Nilton Janino. His task? To collect a cargo weighing 750 tons and deliver it to South America's largest port.
A cada vez que a gente aperta o V+, até 10 por hora, 10 km por hora, ele aumenta a velocidade em 2 em 2.
The cargo is one of the most valued and versatile products on the planet. Iron ore.
The demand for Brazilian iron ore is massive, and Brazil is producing 1 million tons of it every day.
The problem is, between Brazil's biggest iron ore mines and the port is a mountain range. That's where the MRS comes in. A unique combination of purpose-built tracks and trains.
Bom, por enquanto não tem ninguém ali agora. Ah, chegou o manobrador.
Nilton eases the locomotive into position.
Quando ela encostar, vai ser perceptível. Aí eu zero o acelerador aqui, tirando a força do engate. Olha lá, já encostou.
He's now attached his train to the maximum load that this railway is designed to handle. And ready to put it through what could be the toughest test on any railway, anywhere.
Numa rampa considerada também uma das mais acentuadas. Estamos trabalhando numa rampa com 10%, que vale a cada 100 metros sobre 1 metro.
The plan is, when the 10-kilometre railway is fully operational, it will run 24 hours a day. 8 diesel-electric motors driving 8 axles mean that this train can deliver more than 5 megawatts of power, pushing or pulling. That's more than enough to get up that steep 10% gradient. It's the way that the railway handles these slopes that makes it different. And a world beater.
Traditional design of trains involved driving steel wheels on a steel track. That steel gives you the strength to carry the weight and a low friction between the two surfaces. The fact is, we don't want low friction on this. They've had to redesign the whole drive system to keep this thing from speeding away down the hill.
On the steepest parts of the railway, a sawtooth rack lies between the tracks. The power of the engine is diverted from the wheels to drive 3 cogs. They bite into the rack so they can't slip in either direction. And as they turn, the train begins a controlled climb. The rack and pinion system has never before been used to control this much weight. The first fully laden descent complete. Neilton and his train near the end of the line.
Nesse momento estamos chegando no pátio de Raiz da Serra, onde a gente vai deixar os vagões que nós trouxemos procedentes de Paraná.
It's not just a 10-kilometre trip that they've completed, but a 4-year journey to deliver the only railway capable of moving loads this big, down slopes this steep, and feeding the world's unquenchable thirst for iron. Five engineering marvels, but which of them is the world's ultimate extreme railway? The Sprinter, the Italo, the weightlifter, the MRS? Or is it Switzerland's Lochberg base tunnel? South Africa stakes its claim with its 4-kilometre-long Transnet train. But what about Turkey's Marmaray, stretching between 2 continents? Our current leader is the Italo, but that could be about to change, because for the next category, we're going underground. Which extreme railway has the longest tunnels? In 5, the MRS, because its entire length is above ground.
Okay, so this railway doesn't actually go through any tunnels. However, it's only in last place because instead of taking the easy route of going straight through, it actually puts the effort in to go up and over the mountains.
4th is the super long Transnet. It passes through one tunnel, 780 metres long.
But consider this, only a fifth of the train is in there at any one time.
And then comes the Italo. Its longest tunnel is 6.7 kilometres.
6.7 kilometres of tunnel may seem like a lot, but when you're going 300 kilometres an hour, you're through in under a minute and a half.
In second place, the Marmaray with 12.5 kilometres.
Some of it's underground, some of it's underwater, but extra points scored here for bridging the gap between 2 continents.
So at number 1, with 34.6 kilometres, making it the longest land tunnel in the world, it's the Lochberg base tunnel. And it's what it passes through that really counts.
At its deepest point, this tunnel sits under 2 kilometres of solid rock. That's the equivalent of 2.5 times the world's tallest building.
The Lochberg base tunnel slices through the Swiss Alps. It's an extraordinary piece of engineering. But what makes it great also poses a threat. At its midpoint, any train is more than 17 kilometres from daylight, or fresh air, or, if there's an emergency, help. That's what keeps Daniel Pixley awake at night.
This work is very important. If we don't do this on a regular basis, we could not keep the operation of the tunnel going.
Daniel's work is critical maintenance. A never-ending cycle of repairs and checks intended to ensure that the world's longest land tunnel is also the safest. Sunday, 2200 hours. The railway has closed. Daniel is about to lead his team into the tunnel to begin a weekly 8-hour race against the clock. Get in, get it all done, and get out before the line opens up again.
The first intercity in the morning comes just shortly after 6 a.m., so the work does have to be completed in time.
This has been the routine ever since the tunnel opened. It's taken a massive investment on the part of the Swiss authorities. It's demanded the removal of a huge amount of rock. Normally, 90 trains a day pass through the Lochberg-based tunnel. But now, the only thing on the track is a dedicated maintenance train, kitted out with everything that the team will need for their night's work. The team fights a constant running battle with floods. The fact that there are thousands of meters of snow-capped glacial rock above them means that water is always seeping into the tunnel. Unchecked, it could corrode the tracks, making them unsafe, or even short-circuit the 15,000-volt power lines. Both are a serious threat. And though there is a whole network of drainage pipes, the water's very high mineral content means that they quickly become blocked.
Hauptherausforderung oder Probleme, die wir haben, sind starke Verkalkungen, zum Teil bis zu 2/3 die Rohre verkalkt und zu, oder zum Teil auch ganze Verschlüsse, die wir dann mit Fräsrobotern auffräsen müssen, damit der Durchfluss wieder gewährleistet ist.
Before the tunnel reopens, they'll have to flush out several kilometers of pipes. But they'll also have to guard against a much bigger threat.
Now, the most dangerous thing that can happen with a tunnel like this is a fire.
Everyone working on this railway knows that a train fire in a tunnel this long would be the ultimate disaster.
The world record of walking or running away from a burning train is roughly 500 meters, so it's extremely important that if, in case anything does happen in the tunnel, that people can actually get to a safe place. And that's why having a ventilation and a pressure system like this is extremely important.
Smoke is the greatest enemy, and the first line of defense is these fans. Engineer Andre must keep them in top condition so that in an emergency they force smoke out.
Wir haben die Arbeit, diese Jetlüfter zu putzen, damit sie im Ereignisfall sauber und ordentlich funktionieren.
In that situation, they function as part of a bigger system. Because the only way for the railway's designers to guarantee passenger safety was to create another tunnel, running the whole length of the main one. It's intended to function as a safe haven and a way of bringing help. 108 linking passages connect the two tunnels. And here is where it gets clever. The rescue tunnel will only be of use if it can be kept free from smoke, no matter what is happening in the main tunnel. So fresh air is constantly pumped into the rescue tunnel and kept under slight pressure. Vents suck the smoke out and away, while heavy-duty doors create airlocks.
So we've just entered this pressure chamber. We'll now be closing the door behind us, then build up the pressure in this pressure chamber, and then we'll be continuing into the other part of the tunnel system.
Through the course of the night, every chamber, vent and drain is checked. It's not until 5:30 a.m., with just a half hour to spare, that the job is finally finished. Only then can the world's longest land tunnel open for business. So, after 3 rounds in the battle to determine the world's ultimate extreme railway, the Italo's still out in front. But let's move on to our 4th category. And here it's not just what you do, it's how often you do it. How many trains run on each of our railways each day? We're talking about frequency. In 5, the Transnet. If you're an unlucky train spotter, you might wait 2 hours to see one. Around 12 of these trains run a day.
Yeah, there are only 12 trains a day, but that amounts to over 50 kilometres of rolling stock.
Next, our other heavyweight, the MRS. This railway can send a fully laden ore train to port every hour of every day.
The surprising thing about the Logistica is it goes slower on the way down than it does up. But on the way down, it's fully loaded.
3rd, the high-speed line that carries the Italo train, 50 times a day.
Trains occupy their own specific niche. They are fast, they are reliable, and they just deliver you from the city centre to the city centre.
At number 2, trains pass through the Lochberg base tunnel at a rate of about 5 an hour.
There are 90 trains a day that cut straight through the middle of this mountain, completing in minutes a journey that beforehand would have taken hours.
Which means that our winner in this category is Turkey's awe-inspiring Marmara project. With a train as often as every 2 minutes, carrying tens of thousands of people every hour between 2 continents.
It's not just a series of underground tunnels. It's a highly complex machine.
The tunnels of the Istanbul Metro. These are the arteries of a supercity. They're relied on by a population of almost 14 million people. And as the morning rush hour begins, an army of engineers is also rushing. Battling overrunning schedules and escalating costs to complete the construction of what will become, at 58 metres below sea level, the deepest immersed tunnel in the world.
The heavy work is done here, construction work is done. Right now we are working here for the finishing work.
For engineers like Gökhan Yaralu, this is a once-in-a-lifetime job.
This is so exciting for us, especially the engineer cannot get that kind of chance to get experience in his life, and we are so lucky.
But digging deep is only part of it. The real problem, and the reason why the project must be completed, is this. 2 kilometres of shipping channel, better known as the Bosphorus Strait. Traditionally, it marks the boundary between Europe and Asia. But it also divides Istanbul. And it divides the metro too, so that it's not 1, but 2 systems. Crossing the Bosphorus means taking a 15-minute ferry ride, or joining the traffic on one of the bridges.
Bugün İstanbul'da 2 tane Boğaz Köprüsü var bildiğiniz üzere.
Haluk Özman believes that this has to change. That's why he's leading a project which is fraught with danger and difficulty. And the more you look at it, the crazier it seems.
Böylelikle Avrupa'nın en doğusundan, en batısından Asya'nın en doğusuna kadar kesintisiz bir demiryolu ağı oluşturulmuş oluyor.
Though there are more than 150 other subsea tunnels around the world, this one has a whole new level of complexity. First, the seabed is made of soft rock and shale. It's not stable enough to drill a conventional tunnel through. It would just collapse. Second, the Bosphorus itself. Aside from being a stretch of water with very strong currents, it's also a vital shipping channel. It cannot be obstructed. Finally, And this is a key detail. This is an earthquake zone.
Önümüzdeki 30 yıl içinde 7'den büyük bir deprem olma olasılığı şu an mevcut verilere göre %65 mertebesinde.
So, for an extraordinary set of problems, an extraordinary solution. They would build the tunnel on land, transport it in sections, and then sink it with complete precision into place. There are 11 sections, concrete tubes averaging 100 meters long and weighing 55,000 tons.
Bunların her biri 98,5, 110 ve 135 metre uzunluğunda tüp elemanlar ve 2 giriz olarak tasarlandı.
What followed was a millimeter-accurate two-stage operation. The tubes were lowered very slowly to sit in trenches scooped out of the seabed. Then, the bit which really proves the engineer's skill, joining them up with the land tunnels.
Drilling two separate tunnels through the rock face and hopefully meeting up with that preformed section. I mean, you've got to be good at your job to get that right.
When, and only when, the engineers were absolutely sure that the sections were perfectly aligned, they knocked through the tunnel ends and joined it all together.
This is going to the European side, and this is the undersea, and the sea is starting from this point.
The tunnel is strengthened to withstand pressures in excess of 500 kilograms per square centimetre. But it will take more than strength to survive an earthquake. That's why the joints at the end of each section are actually made of rubber. They'll flex and bend with the movement of the earth. Though the tunnelling's now completed, there's still a world of work left to do. 3 new stations are under construction, and a whole fleet of specially built trains. They will be computer-controlled and monitored centrally, so that the line is always carrying the maximum number of passengers in the most efficient way possible. That's how they'll be able to send trains through at a rate of 1 every 2 minutes. And most importantly, every day, 1 million people will use the Marmaray project.
This is one of the great construction projects in the earth.
So, 4 categories down, 1 to go. Wait. Then we find out which is the world's top extreme railway. Five extraordinary rail systems rated against 5 key measures. But which is the ultimate? As we look at our final category, 2 railways, the high-speed line which carries the Italo and the Lochberg base tunnel, are vying for first place. So, this contest is going to be decided by a weigh-in. Our final category, which railway carries the heaviest trains? In 5, travelling beneath a city and beneath one of the world's busiest waterways, a standard train on the Marmaray project weighs 370 tons.
I find this structure incredible because it's the deepest submerged structure in the world, but it also connects Europe to Asia.
In 4th comes the Italo high-speed line. It loses ground here because it carries only high-speed trains, and the designers worked hard to keep their weight down to just 410 tons.
For a high-speed passenger train, this is seriously light. And as every engineer knows, the lighter the vehicle, the faster it goes.
As we've seen, the MRS is a powerful beast. It's hauling 750 tons.
That's 750 tons compacted into a really tight space, designed to go down a very steep track.
Still, the Lochberg base tunnel is in a different league. It carries both passengers and freight, and the heaviest train that runs through here weighs 3,200 tons.
The thing that's amazing about this tunnel is that it's so long that trains have to have automatic health checks before they're allowed to go through it to make sure they can make it to the other side.
That makes our winner in the weight category, and it was always going to win this, the Transnet. It's 13 times bigger than its nearest rival. Snaking their way across South Africa, the trains of the Transnet line get to be heavy by being long. 342 wagons, 4 kilometers.
Actually breathtaking. When we first got onto the trains, we couldn't believe the trains were so long. I can't describe the feeling until you sit behind the controls.
This is Dean Gowder. He's been a train driver for 13 years. And today he has one task: to get this train to its destination without letting it pull itself apart. Noon, the mining town of Sishen, Northern Cape Province. Waiting for the go signal. Although the join between each wagon is made with steel knuckles weighing 45 kilograms, the forces involved in moving this machine are powerful enough that they can simply snap in two. And that's entirely intentional.
It's a clever design because that's the weakest point in the coupling system. Then you don't damage the rest of your wagon. You only damage the knuckle, which can easily be replaced.
Martin Mulder is the train's engineer. He'll be making the journey south with Dean. The challenge they're both battling is that the power involved in moving a 34,200-ton mass is incredibly hard to control. Just getting going requires extraordinary skill. And if Dean doesn't apply power in exactly the right sequence, this run will be over before it started.
Okay, we're taking power to depart. We do it one notch at a time first. We release the brakes, then we take one notch at a time to get into motion. You can't just take off because then you might break the train.
The railway runs on a single track, from Sishen to the port of Saldanha. Every time one of its 35 trains makes the trip, it's carrying enough iron ore to make 34,000 cars.
Operating train 1001, warning signal Selco green.
With a train this big, any kind of gradient, even one so small we'd barely notice it, is a major threat. As soon as the front of the train heads down even the gentlest slope, it starts to gain momentum. It will try to accelerate. But given the Transnet's length, it may well be that at the exact same time, its rear is struggling uphill. The train will try again to tear itself apart, unless Dean simultaneously brakes at one end and accelerates at the other. To stop the train breaking into pieces, Dean depends on not one or two, but 6 engines, spaced evenly along the train. They're connected to the front cab using what's called a radio-distributed power system. It means that Dean has push-button control of each locomotive, even the one at the rear, 4 kilometers away. It's a high-tech solution, which enables him to maintain a uniform speed all the way along the train.
the driver needs to know where a train is. He needs to know very well the topography of his line and where the rest of the train from his knowledge of the line is lying.
When they reach port, the ore will be offloaded, continuing its journey by sea to the iron foundries of Asia. But for the next few hours, all 34,200 tons of it rests in this man's control.
I think it was for one of my birthdays, and my parents bought me a small train set. But it's nothing compared to what we play with nowadays.
So, 5 extreme railways, 5 extraordinary feats of engineering, each a world beater in its own key category. But which one is the overall best? To find out, we have to take every test into account. The tunnels, the steepness, the speed of the trains, their length and their weight. Here's the final result. Hauling its way into 5th place, the mobile mountain that is the Transnet. Grinding into 4th with another load of iron ore on its back, the MRS. Istanbul's Marmara arrives 3rd. While streaking into 2nd place with its huge top speed and sports car paint job, it's the Italo. That means the winner, carving its way through kilometre after kilometre of alpine rock like a knife through Swiss cheese, it's the Lochberg Base Tunnel. The technology that keeps it safe is the most advanced available. It is also, bar none, the longest land tunnel in the world.
So what do you do if you've got the Alps in the way of your rail line? You cut a tunnel through it, moving 60 million tonnes of rock. I mean, that's audacious.